a disinfection system developed by Faro S.p.A, a benchmark for LED lighting and for indoor environments. This is Sidèrea BKL, the first Faro ceiling light, entirely designed and manufactured in Italy, capable of reproducing the same quality as natural sunlight, reducing the risk of contamination by viruses and bacteria in indoor environments. I'm Paola De Vescovi, and on behalf of Faro, I'm here today with Professor Gabriele Messina. Good morning, Professor. Associate Professor of General and Applied Hygiene of the Molecular and Developmental Medicine Department of the University of Siena. And with Professor Gabriele Cevenini. Good morning to you too, Professor. Full Professor of Bioengineering of the Medical Biotechnologies Department of the University of Siena, who have certified this new Faro product. Professor Messina, I'm going to start with you. I want to ask you, in what type of laboratory have your tests been run?
Good morning. To begin with, the tests were carried out in the part by the University of Siena at the laboratories of the Molecular Medicine Department. Other tests were conducted at the Toscana Life Sciences, which is an important science park in the southeast of Tuscany, where there are biosafety level 3 laboratories. We necessarily had to conduct tests in these laboratories for certain types of investigations, as there are a number of rules and safety levels you need to comply with.
I know these tests were run on some viruses and bacteria, as well as on SARS-CoV-2. So I was wondering whether these tests, and this question is again for you, Professor Messina, were carried out on the virus itself or on a surrogate.
The tests were run on the real virus. We wanted to perform them in this type of context, as I said, in a biosafety level 3 laboratory, because we did not want to encounter possible distorting elements that may arise when you use surrogates during investigations. We decided to use directly the live virus and therefore limit as much as possible those confounding factors present in any type of investigation.
The next question is for both of you. I noticed that in your report you make reference to NearUV 405 rays. What are they? And how do they differ from UVC rays?
I'm happy to reply. Well, NearUV rays, 405 indicates the wavelength of these rays, 405 nanometers. These are rays of the visible spectrum. So we are talking about photometry as distinct from radiometry, which is below 400 nanometers. Therefore, they are centered on the 405 nanometers. LEDs that are narrowly centered since they are below 400 nanometers with less energy. The visible light wavelength is between 400 and 780 nanometers, so they are visible and they have a color, ranges between violet and deep blue. How do they differ? They have both positive and negative characteristics. As everything else, there are pros and cons. In terms of reflection and transparency, they are significantly better than UVC rays that are universally known as disinfectant rays, and therefore lend themselves to applications where reflection and transparency can be harnessed even more easily. As all visible rays, they can even envelop rather than suffer from, at least to a lesser extent, the problem of shadows. They can certainly be managed more safely compared to UVC rays. Let's say that they are clearly safer. NearUV ray management is a precautionary kind of management. As it happens, when UV rays are used, you need to wear sun goggles when you tan or for similar things we know very well. Consequently, safety is better managed. Clearly, attention should be paid to particular subjects, such as albinos, or those with photosensitivity problems, etc. However, it is generally manageable. On the contrary, UVCs are more difficult to manage compared to NearUV rays. They are more effective from the electrical point of view, so they heat up less to put it very simply. However, they have a slower disinfection dynamic compared with UVC rays. My colleague is more of an expert and will explain this question better. Yes, to put it very simply, one has to consider that the mechanisms of action used by 405 nanometer rays compared to the standard 255 nanometer light are largely different. The former, that is near UVA rays, act mainly on the stress they produce on microbes as well as viruses, while as far as UVC ray goes, basically their main mechanism of action is the alteration of microbial multiplication. And consequently, microbes are no longer able to self-replicate. A microbe that does not self-replicate is basically that it's not harmful to your health, at least as far as the environmental context is concerned. A couple of words on what Professor Cevenini has already mentioned about the management of near UVA rays, that it is made easier due to their very manageability. That is, whilst with UVC rays, one has to be particularly careful for potential risks for the eyes, for example, or also for the skin. Near UVA rays basically represent a frequency of light already present also in the sun. As we know, when one is intensely exposed to sunlight, there are no particular damages. Well, the action of the biocide is mainly exerted on structures in the case of near UVA rays and on replications, alterations in the case of UVC rays. These are the dominant mechanisms, and clearly there are some gray areas in reality where mechanisms overlap. But if we really had to schematize, I think it would be put down to what I have said.
Therefore, they are absolutely safe for the professionals who work under these rays.
They are safe, provided that certain precautions are taken. Even being intensely exposed to sunlight is something that is harmful to your health. There are a number of rules, also in the case of near UVA rays, one needs to abide to. And when you do, well, in this case, with the appropriate precautions, one can reasonably think that, except in particular cases mentioned by Professor Cevenini, they can be used safely. Sidèrea BKL perfectly complies with all of these measures without any problems.
If things are done, taking the necessary precautions that are clearly necessary, there are no particular risks for the professionals.
It's almost like taking precaution when sunbathing at the sea or something like that.
Sidèrea BKL is also effective against suspended microbial load, so it is suitable to small rooms and with little ventilation too. Is this correct, Professor Cevenini?
Well, we have conducted tests that showed that with stationary air and with sufficiently long times, I mean hours, not minutes, obviously also several hours, let's say about 10 hours, there's scientific evidence showing that near UVA technology can reduce environmental contamination, significantly even by 90% or more. So, clearly I repeat, with stationary air. Therefore, in situations where doors are not opened and closed, etc., so in those moments when the room to be disinfected is closed, maybe at night, or at some different times when the room or the environment to be disinfected is considered.
Another question for you, Professor. Is the air purifier an alternative or a complementary tool to Sidèrea BKL?
Well, what we call air purifier is clearly a complementary tool. I would like to better clarify this point. So, this tool acts on air. This means that an air purifier acts on air only, and not on surfaces, because it is typically made of UVC lights, which need to be checked very, very carefully for safety. In other words, basically, UVC lights must not come out of the casing, which acts on the air entering these systems. Conversely, Sidèrea uses near UVA light and therefore does not have these problems and is specific for surfaces. Let's say its action on air and it's not considered, it is less important. So typically these systems are also used in a complementary way. That is, both are used to complement each other.
Professor Messina, we often hear the terms disinfection and sanitation as interchangeable terms, but they actually refer to actions having completely different effects. Would you mind explaining what the main differences are?
Of course, and I would add the term sterilization too. When we say, for example, and I start from this, sterilization, practically what we mean is the process that kills practically any living microbiological form. On the other hand, the terms sanitation and disinfection, especially nowadays, have led to some confusion. As a matter of fact, if you see the term in its standard definition, as far as sanitation is concerned, it generally means disinfecting and cleaning surfaces. And what does that mean? That when there is a lot of dirt from both organic and inorganic matter, microbes, etc., generally we refer to cleaning and removal of this dirt. The disinfection component instead refers to the killing of microbes. And this killing of microbes can take place through different methods. One of these can be precisely light, and it can also be of a chemical type. And this doesn't mean, however, that disinfecting does not necessarily imply in itself removing. Is that clear? Therefore, sanitizing means disinfecting and removing. As far as disinfection is concerned, this is a technique that applies to different types of technologies. And this basically means reducing the microbiological component, and reduction that can be achieved by killing or removing, or, example, by diluting. These systems that act by dilution, that is, they decrease the presence of these microbes, and consequently, this is also a result of disinfection. A filter that mechanically blocks the microbiological components basically performs disinfection in some way. Therefore, they are a little more complex. Speaking of surfaces, I would say sanitation is correct. More specifically, the term disinfection is used in various types of contexts.
Then this light produced by the Sidèrea lamp protects us from viruses and bacteria. In simple words, Professor Cevenini, how are we protected thanks to this light?
So as I said earlier, but I'm happy to add additional information, light, the visible light that somehow we have all day long, has a wavelength of around 400 nanometers. A nanometer is 1/1000th of a millimeter, and so of a meter, sorry. So it's a very, very small amount. The light around this wavelength creates in microorganisms, mainly bacteria, but also in other microorganisms, so also viruses, etc., some oxidative processes that affect, compromise the membranes and structures of microorganisms. And so they basically kill them. To use a term that is not exactly technical and scientific, but they do kill them, they deactivate them. The light around this wavelength creates in microorganisms, so they actually remain in the environment. So that's why my colleague, Professor Messina, has explained the concept of sanitation well, differentiating it, the concept of cleaning, etc. I would also like to add along these lines, not all languages translate these terms in the same way. So we have been given all the definitions in the Italian language. For example, in English, the terms have a slightly different meaning. Maybe my colleague may add something to this respect. Well, basically, put in a nutshell, we use the visible light, which is near UVA, let's say UVA light. So it is near UV light, but it's not exactly UV light, except with a small part which is manageable, as we said earlier. In terms of safety, on which Sidèrea has devoted a good part of their project based on what we know, and somehow it acts with different processes from those of UVCs, which are some kind of nanometric scalpel. That is, in practice, they're like scissors that cut the DNA. In this case, however, the highest near UVA wavelength in the visible spectrum creates some oxidative processes. Therefore, in some way, it wears out. It compromises the structure of our microorganisms. It is basically a form of stress. It generates prolonged stresses that in the end cause the microorganisms to give in. This is basically the mechanism. There's one thing I can add, however, in this respect with regards to UVCs, as well as to near UVAs. You must remember you shouldn't disregard the standard actions required for sanitation or disinfection purposes because, as I said earlier, the residues of microorganisms that remain must be removed anyway. And in any case, is any type of technology that can be used must be used along with what is already available, and it is right that it should be used. because sometimes a technology is thought to be able to remove or to override all those types of attitudes regarding disinfection, and this is not the case, however. Indeed, these are mechanisms that practically support environmental hygiene-related actions. In this case, however, one must not disregard the standard actions that must be performed through sanitation, standard cleaning, and disinfection, and that we should bear in mind because paradoxically, they could only have negative repercussions on us.
I see. So that means that the effects produced by Sidèrea make it possible to complete and enhance what is already available, as you rightly said, and which is already being used.
Exactly. They must be seen as complementary elements. There is already robust scientific evidence, especially with UVCs right now, but something is also emerging with regard to near UVA rays, where in fact the implementation of these technologies, especially in the healthcare sector, is able to significantly reduce correlated infections. Consequently, less money is spent on problem management, and above all, fewer deaths occur that may be caused by assistant-related infections.
And I was also reading the percentages in your report. The percentages, and I apologize for using an unscientific term, however, the effect on certain bacteria, including SARS, while the percentages are very, very high.
Yes, that's right. The percentages that you see result from a controlled investigation setting. Clearly, it becomes very important, but this is already being done in our scientific activity to study also real-life contexts. Real-life contexts, let's say, are much closer precisely because they are real-life contexts to what is the real effectiveness of the devices that are being tested. Generally, we start from that are conducted in control settings, and then we move on to real-life settings where you have the real experience of the constraints and of the real effectiveness of a device. I don't want to dwell too much on the details. We can say that it is right to conduct a number of investigations following the Union ISO standards, that is, all those regulations which make it possible for the test to be repeated. However, one often overlooks the fact that all these tests must be conducted following these well-made and written protocols. They do not relate to real-life contexts. And between the real-life context and all the laboratory tests, there are big differences. We believe that the truly final tests that can really provide a guarantee and provide an extra level of safety are precisely those conducted in real-life contexts where we live and where no one is under a hood, as it happens in a laboratory. Yes, I also confirm that. Even if we conducted the test for Sidèrea, also with the goal of starting with control tests and then possibly move on to real-life contexts. So let's say we conducted them very carefully, and the results are those you can read in our report.
Professors, thank you very, very much. Professor Messina and Professor Cemenini, thank you for your availability and also for highlighting and exploring this system that, as we said, will make what is being already done in dental practices even more effective. Thank you. Thank you again for being here.